am going to teach one of the important chapter of chemistry, that is organic chemistry. So in organic chemistry, we will be dealing with these compounds like they are made of carbon atoms, they have hydrogen atoms also, and they may contain oxygen, sulfur and nitrogen, even halogens also. So first of all, the next one is what are organic compounds means. They all have, most of them, they have covalent bond. They have covalent bond. 1 point. Second, they have low melting point. They have low boiling point. They are flammable. They are soluble in non-polar solvents, and they are not soluble in water. They are organic compounds. Next one, if I just discuss the next point about this organic substance. The first member will be in this organic chemistry. First member will be this alkane. Another we will have in IGCSE, we have alkenes also. Alkanes and alkenes. See the difference. ANES and ENES. The difference is here. ANES and ENES means this group. So in future we will be discussing what this group is called as homologous series. Homologous series. So one homologous series is alkane, another homologous series is alkene. All the members in this group, they will end with ANE, and in this group all the members, they will end with ENE. So alkanes, even they have general formula. They have general formula. For example, if I talk about alkanes, they have general formula CnH2n plus 2. And alkenes, they have general formula CnH2n only. So here, if you the easiest way is you just see number of carbon and number of hydrogen. The relation is hydrogen will be just double plus 2. Here just double plus 2. What about this? If you see another one, here number of hydrogen will be exactly double of this. For example, if I have got C4, directly I write H8. 4 and this 8, just double of it. Here if I write C7H, that times 2 plus 2. So 7 times 2, 14 plus 2, 16. This is the member. The formula is this, molecular formula. The molecular formula is this. This one is called butene. This one is called as heptane. The name is heptane. This is all I am going to discuss in this chapter. So in for example, here all the compounds mostly they have they'll be sharing. So they'll form covalent bonds. You know, this is how they are sharing. One is shared here, another is shared here, another is shared here, another is shared here. So this is called covalent bonding. So all covalent bonding. This will be covalent bonding, and the first member of alkane series is methane. First member is methane. So the children have to remember, in case of all the organic compounds, you know, the carbon will be the main element. So always around carbon you should have 4 arms, 4 bonds. Add anything, maybe you can add chlorine, maybe you can add hydrogen, maybe you can add bromine, maybe you can add anything. But around carbon there should be 4 bonds, and this is called golden rule of chemistry. So while writing the formula, the molecular formula, actually it can be written in many ways. Sometimes we are showing bonds, sometimes we don't want to show bonds. So here this is the formula where I am showing all the bonds of methane. But here I have just removed the bond, I just condensed them. So it is CH4. For example, the next member if I want to write, so 2 carbon here and rest all are hydrogens. If I write the molecular formula this way, all hydrogens here, all hydrogens here. So this is expanded structural formula showing the bonds. If I condense it, it will be C2H6. This is the molecular formula, and here the name of this is methane, the name of this is ethane. As previously I told, all the members they will end with a particular suffix, same suffix, that is called ane. So here they will end with this. The children have to understand different kind of formulas. For example, if I am writing like this, CH3, CH2, CH3, and 3 carbons are there, I will call it as propane. The name of this is propane. ANE, propane. Now, if you just, I don't want to show hydrogens, I just don't want to show hydrogens, then this compound, I mean, the formula will be different. Now, this is the formula, and we call it as skeleton formula. Skeleton. I mean, that, you know, like human beings, they are showing only bones. Another one. If I remove all these bonds also, I don't want to show the bonds, only the midway you can say. So it will remove all H bonds, so it becomes like this. And this is also a skeleton formula. Now I just want to remove carbon also. So that's only, what is that? I'll write here. One carbon is here, another carbon is here, another carbon is here. So this is line structure, and we call this one as line structure formula. So I mean, easy. Mostly we use these kind of formulas in higher classes. For example, if I write like this, what is the name of this? 1, 2, 3, 4. So it's butane. Easy? It's butane. If I want to write ting. Now 1, 2, 3, 4, 5, 6. Hexane. Okay, but if I want to show double bond, I can put here double bond. Now to add something extra here, for example, I am adding here CH3. It is like this. So if it is double bond here, we will add E and E. This I will discuss in later. Names of alkanes, we will have names of alkanes here. First of all, as I discussed, all will end with ANE. They are called homologous series. So this alkane series is there. In this first member is met, then H, then prop, but, then we can write pent here, ANE, pentane, then hexane, then heptane, then octane, nonane, decane, like that. So first carbon CH4, 2 carbon ethane, propane, butane. So pentane, same, 5 carbon. 1, 2, 3, 4, 5, and hydrogen here, hydrogen is here. So all right, like this. So this is the formula showing the bonds. So this is condensed structure, and number of carbon is here 5. Like this, we give the name of the series alkane. All the members. The other one, if I want to discuss, like 5 carbon compound, pentane. This is 5 pentane, then hexane, heptane, octane, nonane, decane. Just number of carbon is increasing. I can count here 1, 2, 3, 4, 5. Pentane, hexane, heptane, octane, nonane, decane. So the important thing what we can see between two consecutive members is we are just adding one CH2. See, if I just cancel this one with this, this one with this, this one with this, so what is remaining? So I am adding extra one CH2. Every time adding CH2. So if I this one, these two, and these two, and these two, again I got CH2 every time. For the next member, I am adding CH2 group, and I'll get the next member. So it is heptane, octane, nonane, and decane. If the children they learn the names of these, it's very much easy, because just number of carbon they can give the name of this. So naming is done. Now they all the carbon which is there, it is having tetrahedral shape. Tetrahedral shape means the carbon is center and these two are front and is going inside. So all hydrogens are like this in this. So this structure is called as tetrahedral structure. As this I was telling about homologous series, I want to tell you about homologous series. What is a homologous? Because most of the time in IG they ask this question, what are the properties of homologous series? So first of all, what is there? In case of homologous series, they have same functional group. They have same functional group. They will have same functional group. Second point is they have same general formula. Same general formula. They will have similar methods of preparation. We can say similar methods of preparation. Similar methods of preparation. Fourth one I can say about homologous series is, okay, let me revise. Same functional group, same general formula, similar methods of preparation. The consecutive members, they differ by CH2. The members, they differ by CH2. Similar chemical properties. I can add this one also. Similar chemical properties. Okay, similar chemical properties. Then sixth one I can add physical properties. They have a kind of trend. A kind of trend is there. I mean, after this much temperature. That is not trend. Similar kind of trends in physical properties. Similar trends in physical properties. So these are the properties of homologous series. They have same functional group, they have same general formula, they are similar methods of preparation. The members, they differ by CH2. The next one will come if you add CH2. Similar chemical properties here. Then next one is similar trends in physical properties. They are called as homologous series. Like alkane, all the members of alkanes, they have these kind of properties. Next one, another member of this group is, not this group, another group, we call them as cycloalkanes. The word itself suggests cyclic means the figure which completes itself. This is like cyclic 360 degree. So cycloalkanes means they are the alkanes. Obviously, if I am telling that they are alkanes, means they don't have double bond or triple bond. So they are called as cycloalkanes. Means, for example, I want to draw propane. So generally, I will draw propane like this: 3 carbons here, and rest of all hydrogens with different bonds. Right, like this. This is called propane. This is propane. So this I can draw in another way also. Another way, another method what I can draw is, can I draw like this? And I just draw like this. So this, all the 3 carbons are joined together in such a way that they become cyclic. Hydrogen here, and all hydrogens here. So you can write hydrogen here. Now this is a cyclic compound. But the problem is, in this, number of hydrogens are double plus 2, as we discussed already. Here, the formula is CnH2n plus 2. That's why I can write C3H8. But here, C3H6. The number of hydrogen are just double of them. So it is following the formula, general formula CnH2n only. 1, 2, 3, 4, 5, 6. So this is the general formula. But they are the alkanes. They don't have double bond. So how can we discuss? We will see. For example, this is propane. If I write, I have got like 4 carbons. So one here, another is here, another is here, another is here. So 4 carbon. We'll call cyclobutane. Another, if I have another member like this, cyclopentane. This I'll call cyclobutane. And this one I'll call cyclo. See the word suffix. Here you will have prefix. Cyclo will be there. The prefix cyclo will be there. So this is called cyclopentane. So now this is cyclobutane, cyclopentane, cyclohexane, cycloheptane. but the properties of these compounds will be similar to alkanes, not alkenes, though they are following the formula, general formula CnH2n. So sometimes in IG they ask this to confuse, because though the formula is this, but they don't show or they won't show the properties of alkenes. This is something more important. So here are some other structures of this as I have drawn. This is cyclo 1, 2, 3 propane. This is cyclobutane. They have you can write like this. This is cyclopropane. Same way cyclobutane. Or I just see if I write like this as without showing carbon. Cyclopropane, cyclobutane. If I write like this, cyclohexane. See, this is cyclohexane. 6 corners, 1, 2, 3, 4, 5, 6. Cyclohexane. But if I draw this, it will be something different that we are going to study in higher classes, inshallah. Another something more important, very useful, very needed one in case of organic chemistry is isomerism or isomerization. So what is the isomerization means? For example, I have a compound with this formula. This is called butane. So 4 carbons are there, and 4 times 2 8 plus 2 10. Then add hydrogen. 10 hydrogens will be there. Hydrogen, all hydrogens will be there like this. So this is C4H10. So this is called butane. One more thing I can do, I can shuffle the position of carbon. I can change the position of carbons. I can write in a different way. How can I write? Let me try. I can write here in this way. Let me put 3 carbons here. I put 1 carbon here. So still 1, 2, 3, 4 carbon. So 4 carbon. Hydrogens if I put here, hydrogens, as I have told you, we have to be very careful that every carbon should have 4 bonds. So hydrogen, and let me put all hydrogens here. So now, how many? You see, the structure is different. This is structure and this is structure, they are different. But the molecular formula will be same. CH3, and H. So 1, 2, 3 and 4 carbon, so 4 carbon. Hydrogen 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 hydrogen. So we got a definition that compounds have same molecular formula. Compounds have same molecular formula. Molecular, you need to write molecular formula. Most of the time the students they have same formula. Formulas can be of different types. Don't write same chemical formula, because all the formulas are chemical formula. So specifically the children need to write compounds that have same molecular formula but different structural formula. Compounds have same molecular formula but different structural formula. They are called isomers. So one is this, another is this. These two are the isomers of butane. They are the 2 isomers of butane. I can say this isomer is, straight chain. This is straight chain. So I can call N-butane normal. This is branched. 3 carbon here, 1 carbon has gone. So I can call this is branched hydrocarbon. Branched hydrocarbon. This one is called branched hydrocarbon. So we have, I can say there are 2 forms, the 2 way I can write. But listen, if I write like this, 3 straight, and if I write carbon here, this is same like this. There is no change. 1, 2, 3, 4 carbon. It is same like this. Sometimes children they get confused. Can I write like this? No. Or sometimes you cannot put at the end. If you put like this, it's also same. This one and this one, they are same. So they are not the isomers. You have to write the isomer, the position of the carbon should change. So what are isomers? Compounds, they have same molecular formula, but different structural arrangement or structural formula. They are called isomers, and this phenomena is called as isomerism. As the number of carbon will increase, the number of isomers will also increase. For example, if I just want to write, if I want to write the isomers of hexane, okay, hexane means 6 carbons, 1, 2, 3, 4, 5, 6, okay. So the 6 carbons are there, and this is called as hexane. This hexane has different structures. I can write the structures in a different way also. So let me write first 5. 1, 2, 3, 4, 5. No problem. Let me put 1 carbon here. Definitely. Can I write in another way also? Instead of putting this carbon here, I can put here. 1, 2, 3, 4, 5. Yes, and I can put carbon here also. Okay, this is how. So one isomer is this, another isomer is this, another isomer is this. So the name of this one is called 2-methyl pentane. The name of this hydrocarbon is 2-methyl pentane. So the name of this one, if I want to write the name of this isomer is 2-methyl. Simple, very simple. So this is called 2-methyl 1, 2, 3, 4, 5 pentane. The name is 2-methyl pentane because on second carbon, if I start counting from here, 1, 2, 3, 4, 5. So it is on the functional group extra carbon which is not marked. Means the number has not come on this carbon, so this has become now functional group. And if it is one carbon, we call this methyl, just alkyl. Ethyl, if 2 carbon, ethyl, 3 carbon, propyl, butyl, pentyl, hexyl, like that. So this 2-methyl, then pentane. That's it. What about this? 1, 2, 3, 4, 5. Okay, so now on third carbon, simple, I'll write 3-methyl. And pentane. So like this. But again, I just want to clear here. If you write here, from this side of carbon, on this carbon, if you write another carbon, maybe like this. I just want to show. If you write this is same like this because then numbering will be done from this side because we are giving importance to functional group. If the functional group is here, then I will start counting from here. 1, 2, 3, 4, 5, like this. I will go from this side. Or if but functional group is there, so I will go from this side. Same way here. But here, if you go from this side or from this side, will be same. So it is 3-methyl pentane, and so we have got 3 isomers. So, and their boiling points will be different, their physical properties will be different because of change of position of functional group, they are not similar. Their properties will be different. So this is called isomerism. Compounds that have same molecular formula but different structural formula are called isomers, and the phenomena is called isomerism. So here let me clear you one more thing. For example, if you just change the position, like I changed the position of carbon here, it was on second and it was here third. But if I change double bond position, for example, I have a compound like this butene. This is double bond is on on first carbon. So that I think if I change the position of double bond, it will become again a functional group. So here it is 1-butene. The name is 1-butene or but-1-ene. Or second one here is after second carbon, can I write 2-ene butane? 2-ene butane. So the difference are here. They are also functional. They are also isomers. So if I revise about isomers is compounds that have same molecular formula, but different structural arrangement of structural formula. They are called isomers, and the phenomena is called isomerism. Now, how can you give the naming of as I discussed earlier? If you are adding one carbon, that's CH3, we call it methyl. If you have two carbon, it will be called ethyl. Then propyl, like this. Or if it is you have fluorine, you are adding chloro, bromo, iodine. For example, I have three carbon here and I put just chlorine here. So the name will be 2-chloro because the position of this chlorine joining to the carbon is second. 1, 2, 3. Or if I count from here 1, 2, 3. So it is second position. So I will call it as 2-chloropropane. So it is 2 dash chloropropane. 2-chloropropane. This is the name of this. Or if I have instead of this, if I have iodine, 2-iodobutane, 2-fluoro. This can be fluoro also. So it's 2-fluoropentane. Here naming can be given like this. So here if it is 1, 2, 3 and there is methyl. So I'll tell is methyl propane, or specifically if you want to write, see, I can write methyl propane, or specifically if I want to write 2-methyl propane. This will be 2-methyl propane. 2-methyl propane. This will be 2-methyl propane. Here if it is like this 1, 2, 3, 4, 5. So this is 1-methyl, another methyl. So you have to give the names of both. So it is second carbon and fourth carbon. So it is 2, 4. It's 2, 4. How many methyl? 2. So di. 2, 4 dimethyl. 2, 4 dimethyl. 1, 2, 3, 4, 5 pentane. 2, 4 dimethyl pentane. The name will be like this: 2, 4 dimethyl pentane. Okay. If I have one more CH3 here, then what? I have to remove one carbon hydrogen from here, because one bond, and one hydrogen. So it will be now like this. So then I'll write 2, 3, 4 dash trimethyl and pentane, like this. So this is the naming of any alkane or alkene. I mean hydrocarbons. Now you can give the names like this. Easy. Now I have, for example, the naming. I want to name this one. Is first of all, what I have to see is I have to find the longest chain. Number chain is longest chain. 1, 2, 3, 4. If I go like this, 3. If I go like this, this is 4. There is no chain. Okay, if I go like this, 4. So one functional group becomes this. Another functional group is here. This is on second carbon. This is on third carbon. So the name will be accordingly: 2, 3 dimethyl. 2, 3 dimethyl. 2, 3 dimethyl butane. 1, 2, 3, 4 is butane. 2, 3 dimethyl butane. Okay, now here 1, 2, as I have written, 2 and 3 second carbon. So 2, 3 dimethyl butane. As long the number of chain or number of carbon, no problem. The method is same. You have to follow the same method to here. So if I want to give the name of this, it will be like this. First rule is draw the main chain of carbon. Main chain of carbon. Second one is number of chain and place the substitute of the carbon, indicated the number, and add the correct numbers of hydrogen atoms. Like if you want, if there is a formula, how can you write for the formula? The formula is there. How can you write the structure of that? For example, I have got 2, 3 dimethyl butane. Okay, I have got this 2,3 dimethyl butane. So they say butane, so 4 carbons, easy, 4 carbons. Okay, or instead of butane, I have got hexane, Hexane, hexane. Okay, hexane means 6 carbon. So, okay, this is 6 carbon. 1, 2, 3, 4, 5, 6. Now, 2, 3 means on second carbon and third carbon you have methyl group. See, this is how. Now put all number of hydrogens, exact number of hydrogen here, here. So this is, and here also, here, all here. So it will be, if I write hexane means 6 carbon, then how many hydrogens? Remember the formula I told you. The formula I told you is, in case of alkanes, if it is C6H14, it was times 2 plus 2. So you can count here 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. No, 6, 1, 2, 3, 4, 5, 6. So 6 times 2, 12 plus 2, 14. So it is CH3 and CH3. And this is CH3, this is also CH3, and rest is all hydrogens. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. C6H12, is it C6? 6 carbons, yes, and 6H12 plus 2, 14. So this methyl group is added here. Exactly. 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4. 4 are these hydrogens. So the formula will be, on this carbon also like this, on this carbon also like this. So this is the formula, but I have to, now this is not hexane because 8 carbons, 1, 2, 3, 4, 5, 6, 7, 8. So it is octane, no problem. If it is octane, now see, octane means it will be C8H, 8 times 2, 16 plus 2, 18. 18. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Exactly like this. So the name of this will be 2, 3, as I have told earlier. It will be 2, 3 dimethyl, 2, 3 dimethyl octane. This is the name. This is the method of naming. How to name the compound, the organic compound. We just need to. Now, if we discuss about properties of alkanes, so these are the properties of alkanes. First one is alkanes 1 to 4. They are methyl propane. They are gases at room temperature. They are used as a fuels. Second is they have, if you go to more higher hydrocarbons, maybe like 5 to 8, they are liquid at room temperature, pentane, hexane, heptane, octane. So they are very much volatile. They vaporize. They are used to make gasoline. Now they are higher hydrocarbons. They are solid because they have high boiling point. Because we know that as the number of carbon, as the mass increases, their state also changes. The lower hydrocarbons, they are gaseous because their boiling point is less. As we are adding number of carbon, the boiling point will also increase. So we have to be very careful about this concept. When they change this, so things will change. Now the other chemical properties of this will be here. Combustion. First of all, combustion of alkanes. How? Whenever all the hydrocarbons. So what are hydrocarbons? If I want to write the definition of hydrocarbon, hydrocarbons means compounds made of carbon and hydrogen only. Compounds made of carbon and hydrogen only. They are called hydrocarbons. So, for example, alkene, alkyne, they all are hydrocarbons. So we are talking about combustion of alkane. Whenever alkanes they are burned, they will produce carbon dioxide and water. For example, I have got methane. This methane, when it combined with oxygen, it burns to become carbon dioxide and water. We need to balance the equation. Plus energy in the form of heat and light. In the form of heat and light. So carbon dioxide, water, this is called combustion of alkane, combustion of hydrocarbon. So this is what the balanced equation. This is the balanced equation. One carbon here, another carbon is here. So 4 hydrogen, and 2 oxygen and 4 oxygen. So this is balanced combustion of alkane. Now here I must discuss another factor. Here we have supplied sufficient oxygen. So whenever for the combustion there is sufficient supply of oxygen, it will form carbon dioxide, harmless, and water. But if this burns in insufficient supply of oxygen, it will form something else. For example, I have got CH4 plus O2, maybe less amount of oxygen, it will form carbon monoxide and water. This carbon monoxide is very much dangerous. It is poisonous because this carbon monoxide, it combines with hemoglobin inside the blood and forms carboxyhemoglobin. It forms carboxyhemoglobin. It forms carboxyhemoglobin, and this avoids the supply of oxygen to the cells for cellular respiration. I mean, there will be no because of respiration, the body will not get oxygen. So because of insufficient supply of oxygen, the person will will suffocate. So this is the problem. That's why always advisable the room should be well airy. I mean kitchen should be well airy. So that when the combustion is there during cooking, the air should be supplied sufficiently. If there is less sufficient, carbon monoxide will form, and the person who is there in the kitchen for preparing food, they will be in trouble. Because they will be inhaling carbon monoxide. That's why in schools and everywhere they plan for. I mean, unfortunately, if there is fire, how the school will be evacuated, the students will be taken out. And maybe they are taking care of the helipad, they are constructing permanent helipads there, or other because when there is fire, maybe the lift will not work. So other emergency exists. So this is the problem with carbon monoxide. Whenever insufficient supply of oxygen is there, it will give you smoke, and that smoke contains carbon monoxide, and the person will, when they inhale, they will have headache, they will have lot of headache, the vomiting, and person will get unconscious, and if he is not removed from the environment of carbon monoxide, it will die because of suffocation. This is combustion. This is called insufficient supply of oxygen or incomplete combustion of oxygen. Incomplete combustion of hydrocarbons. Like here, so we have because of incomplete combustion, they will get carbon monoxide is highly poisonous, and this is the reason why boiler must be serviced regularly. So this will form methane, and this water and carbon monoxide. So nowadays we are getting carbon monoxide detectors also. So if the level of carbon monoxide increases, they will inform you, and we can be safe. So because of increased technology. Another reaction of alkanes is substitution. The word itself suggests substitution means one is going, another one is coming. Someone is substituting the other. That's called substitution reaction. So for example, this methane, better if I draw like this. For example, this methane is having 4 carbons. This methane is having 4 carbons here, and if it combines with chlorine, if it combines, and let me write like this chlorine, if I write like this, if I write this chlorine like this, it's that. Now, if I want to write this one in this way, here, instead of this I write ClCl. Now what will happen? This chlorine combines with hydrogen and form HCl. Here HCl will form. What about this? This chlorine will come to this place. So the structure will be these three will don't change this all three hydrogen and here you put chlorine. This hydrogen is substituted by chlorine. This hydrogen is substituted by chlorine. So this hydrogen is substituted by this chlorine. This is how. And the product is HCl. This is I must say this is byproduct. Most important product is this one, and we call this chloromethane. We have got chloromethane. Conditions many times there are this condition. Light or ultraviolet rays. Ultraviolet rays or light is required because that light will provide energy to break the bond. Continuously, like in this again, if I go with this again, another Cl will come and we'll see replace one hydrogen, it becomes CH2Cl2. With this molecule again one Cl will come here, then again CHCl3, again CCl4. This is called carbon tetrachloride. And this trichloromethane, they are all important compounds. So this reaction is called as halogenation reaction, or this is also called as substitution reaction. But the condition is here. It should happen in like the condition is we require ultraviolet light, because if the light is not there, the reaction cannot occur, because we require energy to break the bond between chlorine and chlorine. This is covalent bond. Okay, next reaction, if we discuss the next reaction, or let me give another example of, I was telling this, the use of trichloromethane. Trichloromethane means here Cl, 3Cl, here Cl, and this is the hydrogen. So this trichloromethane, so this is commonly called as chloroform and is used as anesthetic substance. Like when I was a student, we used to dissect small animals like rat or sometimes frogs, so we used to put chloroform on them and they become unconscious. Now tetrachloromethane is all chlorine are there, all the sides they are chlorine, so it's called as tetrachloromethane. It is a very good solvent. It is used as a dry cleaning agent. It is used in dry cleaning because it dissolves all these grease and dirt. Actually, when we wear shirts and other clothes, so what happens? Some kind of bags come out of the body and dirt stick on that, and we say that the shirt is dirty. So what they are doing, when they give them for dry cleaning, this will dissolve them. Because if you do this with water, grease cannot be removed. So this tetrachloromethane, the use of tetrachloromethane is this one. Another member of this group is alkene, E-N-E, or will end with E-N-E. So same thing is there. In between carbon-carbon, we'll have double bond. Carbon-carbon double bond means carbon is sharing two pair with another carbon, and one is here, another, maybe I can write here, and here. Sorry, it's like this I should write. So this can be shared with hydrogen and hydrogen. It also brings this, and this also brings like this. So the bonds will be like this. Okay, and here the double bond. So the first member in this is C2H4. They all will end with DNE. The general formula is CnH2n. Double bond CnH2n. Number of hydrogen will be just double to that. They are called unsaturated hydrocarbon. They are called unsaturated. Any hydrocarbon with double or triple bond, they are called unsaturated. How can we identify? Just count the number of carbon and hydrogen. If you count the number of carbon and hydrogen, if they are just double to carbon, we can say they are alkenes. They have double bond in them. And the first member we start with, this is ethene. The structure is this, C2H4. The name is ethene. Remember, previously I have written ethane and ethene. So in this way we write, if I want to go to other members of this series, they are here. Next one, Homologous series, I told you what are homologous series. Compounds they have same molecular formula. Homologous series means they have certain properties like the properties are means the members they differ by CH2 group, they have same functional group, they have same chemical properties, they have a train of physical properties. So in this way the general formula is this one. Next one is like ethene. I have written the structural formula of ethene. Double bond is there, and this is the first member. The diagrammatic structure, see, in case of carbon they are sharing two pairs between them, that's why they have double bond. How to distinguish between alkane and alkene? This is one of the most important, I must say this is one of the most important question which is asked in IGCSE. How can you distinguish saturated, unsaturated? How can you distinguish between alkane and alkene? So we have got bromine water. The important thing is that is bromine water. See, we have bromine here. So if you add bromine, actually the color of bromine, Br is liquid, right? Br or Br2. Br2 is liquid at room temperature. Fluorine and chlorine, they are gaseous. Bromine is liquid and iodine is solid. The color is dark. So bromine, this is liquid at room temperature, the color is brown color. Now this brown color liquid, if I add in this alkene, if I add in alkenes, the result will be different. The result will be different. What is the result? The color of this brown color becomes colorless. Got it? The color becomes colorless. But the same the same bromine water, if I add to alkane, color remains brown. Got it? Let me repeat. Bromine water, if you add to alkene, I am adding alkene, it becomes 1,2-dibromoethane and it is colorless. This is 1,2-dibromoethane because double bond is gone. 1,2-dibromoethane, and this reaction is called addition reaction. This reaction is called addition reaction. This reaction is called addition reaction. Okay. So it's 1,2-dibromoethane will form and it is colorless. But the same thing will be there. For example, I have got ethane. This is ethane, correct? I have got ethane here and I am putting, yeah, you see the difference? Br and Br. Now the reaction will go like this, right? So now what will happen? This will be formed and gone. HBr and this bromine will come here. So the structure will be like this. So here you will have hydrogen, maybe I can write bromine here, all are hydrogen. See the product difference. Here see the product difference. See the difference. Okay, then here is 1,2-dibromoethane, here is only one bromoethane. It's called bromoethane or one bromoethane. This is brown in color, same in color, and this one is colorless. This is colorless. So this is the test. This is the test to distinguish any saturated and unsaturated hydrocarbon. Saturated hydrocarbon will not show this test. Unsaturated will show. So another very important are the properties of alkenes. So first conversion I already discussed. Alkenes they combine with this. Alkenes they combine with oxygen form carbon dioxide and water. The reaction with bromine water, the color of the bromine water is brown or orange in color. Mostly it's actually we call this orange in color. So this orange color of this bromine water when it reacts with this alkenes, this is ethane, so it becomes same. Orange color remains orange. But the same thing if it reacts with ethene, the color if it reacts with ethene, the color will change to colorless. This is called addition reaction. This reaction is called as addition reaction, and the product is 1,2-dibromoethane. Next one, another property of this one is they show the property of polymerization. They show the properties of polymerization. These small molecules called monomers. They are called monomers, small molecules like so many ethene. They combine together at high temperature, high pressure, and presence of catalyst. In presence of these catalysts, they combine and the double bond is broken. They form long chains of polymers. So monomers mean single units, and these single units, when they join together, they form polymers. This polymerization is a complete chapter we will study later. So these monomers and types of monomers, they join together, double bond will be removed here, and they form a polymer. So this is ethene, this is called polyethene. Ethene, this is called as ethene, and this is polyethene. This is how the what is that, reactions of ethene. Now, preparation of alkene. How can we prepare alkene? One method of preparation of ethene is dehydration of alcohol. Dehydrated alcohol is, ethene can be prepared by passing vapors of alcohol over catalyst aluminum oxide. Just then water, from alcohol, water will be removed, so we call this dehydration reaction. From alcohol, if we remove water at high temperature in presence of catalyst, it will form ethene and water. Another is by heating alcohol with sulfuric acid also. You have got ethanol, put sulfuric acid and heat it at 180 degrees Celsius, you will get ethene. This is ethene and water will be there. Another is by vicinal dihalide, means dichloro. You have dichloro, so dichloroethane when it is heated with zinc. So it will form zinc chloride, ZnCl2, and ethene will be produced. These are different methods of preparation of ethene. We can get ethene by different methods.